Hey, what's going on, guys? This week I have more custom parts for this Frankenstein Backdate 911. This is a 1974, and I've just made another custom part for the ventilation system. And believe it or not, this part's gonna allow me to drive in the rain. I've been kind of prepping the car for a big upcoming rally. It's gonna be over 3,000 miles. This guy here is kind of a backdate part. I'm trying to collect the air here in this air scoop. It collects the air and it diverts it into the dashboard. But without the factory pieces, water will also go inside this vent. And right now there's nothing behind there. So the air just pressurizes the trunk area and water will go inside there 100%. So this piece goes behind that vent and it has two ducts that will take air from the vent and direct it anywhere you want. The way I'm doing this is I'm using a factory part from the short wheelbase cars, like from 65 to 68. This is a factory fiberglass part and it normally gets attached to a big blower assembly. I'm deleting all the blower assembly and all the doors and stuff. So these two pieces are designed to go together. And this I've made with 3D printing. It's basically an adapter that allows me to go from that vent into this rain tray. And it has a little tube on here, or a nozzle. So the air can come in, it gets separated, the water comes out via a drain tube out to the bottom of the car. And then, like I said, I can plumb these ducts to the dashboard to get a little bit of fresh air. There won't be any heat through this system. There is a heater, I have connected that as well, but it uses a different ducting system. I'm backdating almost to the 356 era. This is the equivalent part in a 356. It doesn't have a forward-facing scoop, but it has a horizontal grill. Air comes in there, water comes out the drain tube. In this case, the air just pressurizes the front trunk area. And then the air eventually goes through a fresh air system, but there's no hard duct. So you can't really control the air as well in the 356. So I'm doing a little bit of a hybrid kind of 356 idea modified for my 911. A lot of cars will run this thing all the way up. All the G-body cars basically have this guy. And it does essentially the same thing, but it has a blower. So if you're not moving, you're not going to get much airflow. That's why Porsche added this big blower system and a bunch of doors and stuff to direct the air around. This car is a fair weather car, but you know, like I said, if I do get caught in the rain, I can't have the trunk filling up with water. So that's what we're up to. Let's hope it works. This part was designed by me in two pieces and 3D printed from a service. I'm going to use acetone and rivets to bond it together to one piece. It was a little cheaper to order it as two pieces. And like I said, I don't have a 3D printer, but I ordered this from Cloudcraft, which is a 3D print service. It doesn't hurt to have a little bit of this ASA dust to go into the acetone bath. It kind of makes a little bit of a glue or a slurry. But we need to rough up this surface so we get good adhesion. These parts were printed with the holes in them and they do line up really well. So let's see if we can bond this together. Okay, now we rivet these two together. I'm using a washer behind there so it has a It's called a backing washer. Just a little bit more solvent here on these seams. This should basically kind of wick into the surface. Yeah, that's perfect. Seems like that's working pretty well. This is essentially, it's solvent welding these pieces together. So this material will melt in the presence of acetone. And that's what it's doing. It's just melting these parts together. And this wouldn't be a garage time episode without a little bit of welding. So this time we are plastic welding. I don't know why I tend to overkill everything, but this is dolphin glaze. Maybe it says a trained welder, we just want to hide our pinholes. But I think this is going to do it. There are no solvents on this towel. This is just water and a tack cloth. I'm going to put a link to these cloths in the description below. These are microfiber cloths, but they come in a terrible roll. So they're disposable and super convenient for cleaning things prior to paint. You can use it on glass and paint too. Like, they don't scratch. They're just durable. They don't leave lint. They're perfect for paint prep. They come in a roll like this, and you just tear them off. Like a paper towel, but higher quality without any lint. They're fantastic. Just a little bit of SEM Satin Black. And I'm going to do the heavier coats outside because I got the car right behind me. For all intents and purposes now, this is one part. You can barely see the weld seam, and it's plenty strong. So maybe someone in the future might wonder why rivets are there, but we know it's to hold these two pieces together. So now let's make sure, and I've already done this to be honest, but let's put it in the mating part. So I just bought this on eBay. It was like 40 bucks, pretty affordable. So that fits in there like that. The air goes out the top and the water goes out the bottom. One thing that I did to make sure this would fit the first time is I made a paper template using my laser cutter, and of course it fits right inside. So once I was happy with the fitment of this template, that's when I knew that a 3D printed part would be the exact same size as the template. Of course, you know, this is exactly the same. So when the part came in the mail, this was made by a print service. This was revision 4 on the contour. But once I had that nailed down, I knew it would fit. The same is true for this side. This side's a little bit easier. It's just a rectangle, but I made a template for that too, and it fits directly into the car. So this is the exact same size as the factory blower unit. Saves probably about 10 pounds. The mounting hardware for this big system is right here. So I need to do something similar to that. So I have holes in my part that were printed in the part. So I need to make a little metal bracket with a retainer nut that will attach this to the car. We don't really need the press brake for aluminum. It's pretty easy to bend with just a vise. And now that one bend is done, we'll mark it with the actual part. And then this is to accept the 2 holes on the part, but we can narrow it down in the middle a little bit. So I'm just gonna freehand a little hourglass shape on here so this thing is not so obvious to the airflow. So I might just use some tin snips and just carve that out a little bit and make a nice shape. We'll put a hole in the center with a riv nut. So the riv nut hole will be quite a bit larger, but we don't want to weaken it too much, but we also don't want to just stop airflow from coming in. So we'll nibble most of it out and then we'll clean it up with the grinder or the sander. This is a carbide burr. I mean, that looks pretty symmetrical to me. I'll just go with that. I'm just gonna eyeball the center. Looks like the factory threads are M5, so I will do that as well. I'm gonna use a riv nut here. This hole punch is great because the punches have a little divot. And once you line that divot up with the center punch, the hole is right where you want it. So you just have to squeeze kind of hard. Now, the hole is a little bit undersized, so I'll use a step drill and make it the exact size we need for this. You know, just one step is perfect. Done. Cool. And then last thing I need to do is get the holes in that match these holes right here. So I designed this whole thing, so I know the dimension there. So I don't really need the part. I'm just gonna mark the holes on this and then line it up. The nice thing about rivets is they never come loose. Just like that, there are two of those little brackets. See the rivets in there. Between these two brackets and this center rib that was used to join these parts together, this thing is plenty strong. It's got a little twist to it, but you know, it gets encapsulated in sheet metal in the cowl of the car. I think what I'm gonna do is go ahead and paint these satin black, because the aluminum will corrode eventually, and it'll also protect the rivets and stuff. And then I am going to install the top half in the car. The idea behind this is if you ever get any leaves or debris or dust stuck in here, you can clean this thing and then you can put it back. That's what you're supposed to do, I think. And then to fasten these two parts together, I think I'm just going to use these hooks that are designed into the part. And I'm gonna make a little loop, and I thought what I would do is just put some heat shrink over this spring, and the spring will just stretch over and hold it down like that. It doesn't need to be high force. It just has to hold whatever water this thing might collect. The other thing is this is sloped for water drainage, so this one will be slightly longer than that one. So we're gonna have to take off this little screen here so we can get to the screws behind there. And there's a seal that goes behind here too, but I'm gonna install it without the seal just to make sure that we have good fitment here. And then we'll worry about sealing it up in a second. Okay, so hopefully you guys can see, but you know, the zip ties are holding it in place. I just need to get some pretty long screws. They're M5 and they're probably at least 30 or 40 millimeters long. So that's gonna take some special hardware. I probably have them somewhere, but I don't know where they are. But that's the gist of where it sits. Tucks up nice under the dash, and it's going to, like I said, have that drain tray just below it. I don't have the mechanism to hold this yet, but this will go just like that. So yeah, that's the initial fit check. And I seem to like it. It looks like it's pretty good. These vents right here are sort of partially blocked with some paper. Those are the vents that go right up to the defroster. And I'm gonna be connecting those to my heater because I wanna be able to defrost the windshield if we need to. Never mind the wiring right now. I am working on the windshield wipers and also the horn. So I have a couple wires exposed right there, but those will get tidied up in a minute. This is drooping a little bit, but this output here angles up. So hopefully the water won't be channeled upward. It should drain down to the bottom. I've just made these little loops. This is just welding wire, and I just fused the ends together. So I'm gonna stretch that from hook to hook, and that is gonna hold the bottom tray on, hopefully. So this is just a spring that I had laying around. It is stretched and the coils are sort of, you know, stretched out, but it does work. So I'm probably gonna just go with it and just cover the coils with some sleeving, like I said. That way there, it'll just look like a bungee cord. But yeah, it looks like it's gonna work. So let's make a longer one for this side and test it. And to form the hooks, I just have this welding wire, which I think is 1/16 of an inch. And I just use these pliers, which happen to be the exact same width as the tab. And I just bend it into a V. And then I snip off the ends. So I'm left with that, and then I put it in my vise and weld it. Kind of like a keychain. So that's the connection. I thought about making a rubber cord, a rubber bungee, which would be nice, but getting the custom length on the rubber like that takes a little bit of trial and error. So this is a little bit more forgiving for me with the stuff I have on hand. So I found this heat shrink just goes right over the coils. And both sides are on. You know, it's not bad. The shrink tube really changes the way the spring works. It kind of gets stuck in the corners. It's a little bunched up on the bottom. So I may either go with like rubber straps or long O-rings, some kind of like rubber band that would last, or maybe an elastic cord, something like that. Maybe a rubber bungee cord with ends on it. Not sure, but for now, this will get me, you know, the miles I need to go. This will certainly hold up, and it shouldn't change over time. The spring is going to just hold tight, so I do like that. This is the factory tube that I designed my vent for. This stuff is 1 3/8, and I tried to keep it relatively small so that the velocity is high as it comes out the dash. I'm gonna take the clock out and try to direct it right through the clock, just so I can get a feel for how much flow comes through and how much velocity there is. Now, unfortunately, I don't have more of this. I thought I did, but I can't find it right now. So I have this other kind of black tube, and it's not really meant for vents, but I'm going to kind of put the two together and just go for a quick test drive. And then I'll order more of this tube and see if the diameter is correct. I can potentially make it bigger, but I kind of wanted to go with some of the factory sizing, which is why I went with this one. And then for hose clamps, I'm just gonna use these spring type. Obviously this is low pressure. It doesn't need to have the big screw type things on there. So hopefully I'll be able to get these installed. I may have to pre-install the hoses because I kind of made it so it goes up and out of the way, so it's not that visible. So let me get these installed, and then we'll take it for a ride and see how it does. So like I said, this hose is not ideal. It tends to kink, so I'm trying to prevent it from kinking, but that's got the airflow closed pretty far down. But let's just see how it does with this makeshift hose, and then we'll plan from there. So here on the dashboard, I just have, like I said, this hose is just popping out. So I just want to get a feel for how much flow comes out of this at speed. All right, we're going with traffic, and I'm going, this is kilometers an hour, but I'm almost up to, looks like 90. And there's a substantial amount of air coming out of the tube. You're not going to be able to see it, of course, but it's definitely flowing. I can feel it on my face all the way from here. So I'm able to feel that flow even though I got the window down on the driver's side. The other option is to connect it to these vents, which are, you know, just to the side of the ignition key. But these are pretty small, and they sort of aim, you know, a little bit low, kind of to your elbows. So I'm likely just to keep it up here. I think that's the best option. And that tubing is the same exact size. That tubing is the same size as my vent adapter that I made. I'm pretty pleased with the airflow. It's probably a little bit more than I expected, even though that hose is not ideal and it's maybe kinked a little bit. I could definitely feel it. It's coming right at you. So I'm gonna replace the clock with a vent. Now, some of the guys at Pelican Parts have discovered that there is a Ford F-150 vent that's round, and it fits the clock hole pretty well. The back needs to be adjusted for my diameter tube, but if I make a part that takes two of the small tubes and puts it into one big one, it has the feature where you can close the vent. So that's how you turn the flow off. Instead of using levers on the dash, you just close the vent, and that should stop most of the airflow. The main benefit was to prevent water and dirt from filling up the trunk area, because I've been driving this car for a couple years, and every time I drive it, I open the hood to put gas in, and there's always dirt and debris inside. Now all that dirt from the vent is going to get directed into that tray and then hopefully washed down the hole. So let's look at where to route the tubing that goes down to the bottom of the car. I think the factory drain was right here, and I think it went inside this hole, and then it comes out. There's a little cavity here. It comes out here and it goes down into the bottom of the car. Now, unfortunately, the hole is obscured by my battery, so I might need to come up with a different path to get outside the car. I think the hole is just right next to the battery there. I think I'm gonna have to snake the drain in right through here. It'll have to go down into what's normally the fuel pump area, but my fuel pump is inside the tank. So I'm not worried about getting the fuel pump wet. It's just the steering rack, and I can direct it below the steering rack and it'll just go right out to the ground. Last thing I need is the defroster connected and the wiper connected, and then I'm done. I should be done this weekend.